All right, so we're going to do rapid fire 5. These are the 5 questions that I'm going to work on you with. Let's see, I think you can see them all. So we're going to do perpendicular, if you already own that and you feel comfortable. Perpendicular to an original standard form equation, linear through a given point. I'm going to do 5 of each of these. And once we get on a roll, I'm just going to let the numbers speak for themselves. And you look at the numbers, see if you can get the pattern. We can always develop conceptualization and deeper layering of what's going on after midterm. All right, but let's try to get the mechanics of that down. Going to solve an equation. I'll show you the graphical, and I'm also going to show you the symbolic work here. 5 in a row. Going to do some logarithmic work. Going to do equation of one line intersecting with another with some fraction work. And we're going to do some A, B, vertex to C, D, just generically writing the equation that we see and try to get a little understanding of the squaring process. All right, so without further ado, I'm going to give you the one that I got up there. So 4x minus 5y equals 20. And we're going to have it pass through the point 2, 3. All right, and the way this is going to work for the entire video is you pause, you try the next problem. I'm just going to do them all. So it take me 20 minutes here to get done, and you get some practice. All right, so you have to find slope. And finding slope is mx plus b. B is a constant, so we don't care about the constants in this problem. So to get y alone, I'll just keep it on this side, minus 4x on that side. Y is equal to -4 divided by -5, which is 4/5. That's our m, that's our slope. I mean, it should be times x, right? But that's our multiplier. So the change in x is 5, the change in y is 4. The perpendicular is the negative reciprocal, and I want it to pass through 2, 3. So x minus 2 plus 3. There's the perpendicular to the original line. Okay, so I got to get an eraser here, and I'm going to give you another one. 5 in a row, that's 1. 2x plus 3y equals 8. All right, the constant doesn't matter. 3y equals minus 2x, so y equals minus 2/3. So that's my slope. My new slope is 3/2. One line's going up, the other's going down. The first one's going down. The other one's got to go up in order to make that perpendicular. So what do I want it to pass through? How about AB? All right, so I got to get rid of A in order to get B. So when I drop in A, that becomes 0 times anything is 0 plus B. So now A gets me B. That's problem number 2. Let's do number 3. Let's do 5x minus 9y equals ha. That's a constant. Ha. All right, so this time I'm going to move the 9y to the other side because I really don't like dividing by a negative. So my original slope is 5/9. So now it's going to be -9/5 is the perpendicular slope, and let's let it go through. How about happy-go-lucky? Let's get rid of sad. Let's go from sad to happy. I have no idea what I'm saying, but I got to get rid of sad. Yeah, I got to get rid of sadness to bring in happiness. There you go. That made a lot of sense. And in other words, you get rid of the first x with subtraction. If it's negative, then you add, so on and so forth. All right, so that's 3. Number 4. I don't know if there's any way I can do this differently that would be interesting. So 5x minus 99y equals 2,760. I don't know. So what are we going to write? We're going to write minus 99y. I'm going to put on the other side as 99y. I'm going to bring 20,060 to this side. You can see it really doesn't matter. 20,760. Who cares what that is? Because when I divide by 99, I get the ratio that I'm looking for. That's where slope is. Nothing to do with dividing this by 99. Right? It's dividing this by 99 that matters. So there's my slope. This does not matter. I won't do it ever again. So minus 99 over 5 is the new perpendicular slope. So I got x. How about I do minus 4, 7? So what do I write here? Plus 4 plus 7. You'll notice that number changes. This one stays the same. Okay? And that's going to pass through that point at the perpendicular slope to the original last one. All right. So you're going to look at, the only thing I can do is maybe write this. This might feel a little different to you. All right, what if it just had minus y? Well, then it's positive y on this side. And so my slope is 8 to 1. Again, that doesn't matter. So my slope's 8 to 1. The perpendicular is maybe minus 1 to 8. Let's have it go through minus 5, minus 6. Now, minus 5, I'm going to write x plus 5. So my y value, if I put in negative 5 right now, gives me a 0. But I want minus 6. I got the marker. There's minus 6. There's your practice for tomorrow's question, which I will be asking because it's a language class. I want to see if you can speak the language. All right, so now I'm going to go after solving. I'll do the one that's up there. 2x minus 5 squared plus 7. I will be giving you this kind of statement and asking you to graph. You're going to look at that and say it's positive cup shape up. And the vertex is 5, 7. And I'm trying to hit a height of 19. There's a height of 19. 19 is bigger than 7. There's an x here that works, and there's one there that works. I got two intersecting points, and I'm trying to solve for the x value that I put in here that gives me 19. So what am I going to do? Well, I got to go 7 to 19. It looks like I got to go up 7 to 19, 12 units. Oh, if I take away 7, that's 12. So that gives me 2x minus 5 squared. Oh, I got to double things. Well, what am I got to double to get 12? I guess this has to become the number 6. The whole thing here. That whole thing has to become 6. So x minus 5 squared, 12 divided by 2 is 6. Oh, if I'm squaring something and I want to get 6 out, I better start with the square root of 6 plus or minus. So that's what you get over here. You get x minus 5 equals plus or minus the square root of 6. So my final answer is 5 plus or minus the square root of 6. And I'm done. So 1, 2, 3, 4 inverse operations, and you're done. Let's try another one. Let's do minus 2 this time. X minus 3 squared minus 8 equals 10. Okay, so what do we have here? We've got cup shape down. 3, negative 8 is the vertex. And I'm trying to hit a height of 10. A height of 10 is above that. If you think that's intersecting, you're imagining things. What are you imagining? You're imagining that you do the inverse operations. Looks like I got to go up 18 units from negative 8 to get to 10. Yes, I got to go up 18 units to get there. I'm dividing by negative 2, so that's x minus 3 squared equals negative 2 into 18 is negative 9. Oh, so I got to do the plus minus square root. So x minus 3 equals plus minus the square root of negative 9. I hope you know that a negative, we don't leave it in there. We talk about the imaginary aspects of what we're talking about. And I know what the square root of 9 is. I won't leave it like that. I'll write 3. So the answer is plus or minus 3i. I'll put that in a little closer so it's easier to read. There's your answer. So oh, I'm sorry. I forgot to say minus 3 plus 3, right? So x is equal to 3 plus or minus 3i. We're going to check that one out. In place of x, I'm going to write 3 plus or minus 3i. So I got to spread this out a little bit. Minus 2, 3 plus or minus 3i. Oh, what happens to the 3's? 3 and minus 3 cancel. What do I get when I do 3i squared? I get 9i squared. Oh, I did the squaring. Oh, that's negative 9. What's negative 2 times negative 9? 18. What's 18 minus 8? Oh, you know that answer works. Okay, I think that was the second one. Here comes the third. Okay, 4 steps, 4 inverse operations. Can you remember them? Let's look at 5. X minus 2, x plus 2 squared. Minus 7 equals 11. Okay, so you're going to add 7. Boom. 18. You're going to divide by 5. Boom. You're going to undo squaring. Plus minus square rooting. Boom. Add addition of 2 becomes subtraction of 2 on the other side. Boom. There's the answer to the original equation. That was 3. I think we'll do 4. Let's do a minus 2x plus 9 squared minus 7 equals 23. What are you going to do? You're going to add 7. That's 30. You're going to divide by negative 2. That's negative 15. Boom. You're going to take the inverse of the square. That's plus minus square root. I know you'd never forget to write I now. And then positive 9 comes to the other side and becomes negative 9. And if I substituted that in here, you could see that one work as well. Okay, I forget how many we've done. We'll do one more. I hope that's 5. Who knows? So let's see, minus. Let's just do a minus. Now let's do minus 8. X squared, no, sorry, x minus plus 4 squared minus 100 equals 50. What are you going to do? You're going to add 100. So we're at 150. What are you going to do? You're going to divide by -8. Put the negative in the numerator. Okay, I didn't mean to have that, but that's 75 over 4. I can divide both by 2. And if it's negative, that means the plus minus square root is going to be imaginary again, because that undoes squaring. Positive 4 becomes -4. Okay? You've paused the video, you've tried. That should be your answer. If not, you go back and see where you might have stumbled. All right, so that's the second one. Log 8 of 1/4. Okay, so logarithms are finding exponential values, are finding the 3 things we do with an exponent. A minus sign means to flip your answer, take the reciprocal. A number in the numerator is a power, and a number in the denominator is a root. Those are the 3 things we do. Those are the 3 things that might show up over here. But rules of logarithms really are rules of exponents. And here's some exponential activity. A cubed times b squared and a cubed times a squared. You can't do any rules unless the bases are the same. So you have to have a situation like this with addition of exponents, multiplication of exponents, division of exponents, so on and so forth. Those are where the rules come from. All right, so log base 8 of 1/4 is 8 to the what equals 1/4. Unless I can get this the same base, I can't do anything. So 8 could have been written as 2 cubed raised to the x. 1/4 could have been written as 2 to the -2. Now the bases are the same. What's that? 3 times x, 3x has to equal -2 because the bases are the same. So that activity has to equal. So x equals -2/3. So let's go back and let's put -2/3 in. What would I do? I would take the cube root of 8, which is 2. I would square it as 4. What's the reciprocal of 4? 1/4. Let's try some more. Let's do 25, 125. All right, what's happening here? Well, I got to get the same base. So 25 to the what equals 125. 25 is 5 squared, so I'm going to write 5 to the 2x. Equals 5 to the 3. Sure looks like 2x equals 3. Looks like my answer is 3/2. So let's put a 3/2 here. What's the 2 ask you to do? Square root of 25. It's a root. Well, that's 5. Boom, I just used it. I still have 5 cubed. 5 cubed is 125. 5 times 5 times 5. That's our second one. Let's try another one. Let's do a log base 9 to get 1/3. Okay, well, that means 9 to what exponent will transform this base into the number 1/3. Okay, well, what is 9? Oh, 9 is 3 squared. What's the rule of exponents? Multiplication. So that's 3 to the 2x. 1/3. That's 3 to the -1. Right? 3 to the -1 is 1/3. Well, now I have the same base. So 2x equals -1. So x equals -1/2. What's -1/2? A square root of a number flipped. What's the square root of 9? 3. What's 3 flipped? 1/3, right? It's 3/1. I'm flipping it. Those are the 2 operations that you're trying to perform. Let's try another one. All right, let's look at log base 32. No, that's too big. Let's do log base. Let's log base 4 of 32. And is there a base common here? Well, certainly not 4. So I guess you're going to try 2. Yes, 2 squared to the x. And then you go, okay, 2 to the 1 is 2, 2 squared 4, 8, 16, 32. Yeah, 32 is 2 to the 5. So it looks like 2x equals 5. It looks like 5 halves should do it. Again, what's that operation? I hope at this stage you're saying square root of 4. What's the square root of 4? 2. What's 2 to the 5th? 32. And we're going to do it the whole semester. Good luck tomorrow. Good luck Thursday. Good luck Friday. One more. Let's do log base 1/2 equals 8. All right, so we got 1/2 to the x equals 8. What do I see? I see 2 to the minus x. That minus sign flips the 1/2 and makes it 2 to the minus, flips the 2 over 1, makes it 1 over 2 to the x, which is what's above it. All right, so 2 to the minus x is another way of writing that. And I want that to equal 8. Well, 8 is 2 to the 3. 2 times 2 times 2. Okay, so what does that give me? That gives me 2 to the minus x equals 2 to the 3. I guess x is -3. So let's do 1/2 to the -3. What's the first thing I would do with that? I would do the flip. And that gives me 2 to the 3. What's 2 to the 3? It's 8. So you're finding the correct exponent. All right, 2 more problems, which means 10 more problems, or 8. I don't know, I'm losing track. All right, so we're looking at 5/3 x minus 4 equals 3x over 2 minus 5. All right. Now I wrote it this way so that you can see that these mean the same thing. When you multiply a fraction times another number, it's you do the multiplication first and then the division. So I want to make sure that you understand that I could have written that this way as well, interchangeable. All right, so what are we going to multiply by? We practiced this. We're just going to do the first line of work. I think you're pretty good after that. I'm going to put a 6 here because 2 and 3 fit into 6. So the first one is going to have a 6 over 3 influence on 5x. So I'm really doubling 5x. That's 10x minus 24 equals 9x minus 30. If you get there, you got a good shot. I'm going to take the 9x this way. I'm going to take the minus 24 that way. Probably useful for you to have that practice. So do the problem out. Next one, I'm just going to keep the numbers small, but the same concept. Let's do 4x over 5 minus 2 equals 19. That's kind of big. Let's do it. Let's do 9. No, let's do 8x over 3 minus 8x over 3 plus 2. This is our second one. 3 and a 5, I'm going to multiply by 15. All right, and you should get 12x minus 30 equals negative 40x plus 30. All right, I'm going to bring the 40 this way. So that's going to be 52x. I'm going to bring the minus 30 that way, equals 60. So x is equal to 60 over 52, which is equal to 30 over 26, which is equal to 15 over 13. Be nice if you could get there. All right, next one, that was second one. Third one, rapid fire here. Rapid fire, 5 problems. Okay, let's do negative 2x over 7 plus 3x. Let's do 3x minus equals minus 5 plus about 2/3. All right, so nice thing to do here is get rid of the fractions. I see a 3 and a 7, I'm going to multiply by 21. So 7 to the 21, so I should get minus 6. I should get 63x. I should get minus 105. You're taking more time with this. And 3 goes into 21. 7 times 2 is 14. Oh, good. There's no fractions anymore. So this is 57x. And that's going to be minus 91, I believe. Yeah, that's right. So x is equal to minus 91 over 57. And I'll develop this concept graphically for you after midterm, so you get a better sense of what you're looking at. We'll do one more. I hope I did enough for you. Remember, you're taking your time. So let's look at minus 8/3 x plus 5 equals minus 7x over 4 plus 10. All right, so I'm going to multiply by 12. So negative 32x is what I'm going to get when I divide that first and then multiply. 12 times 5 is 60. 4 goes into 12 3 times, so minus 21x. And 12 times 10 is 120. All right, I'm going to bring the 32 that way. So if I add 32, they are 11 apart. The positive wins. All right, the positive wins. I'm going to subtract 120 from 60, so that's minus 60. So x is equal to minus 60 over 11. Okay, and you're taking more time with that, obviously. You have not been doing it for 45 years. All right. So now we're going to look at, I think that was enough practice for that, I hope. Now we're going to look at parabolas. I'm going to look at 5, 7. So what do you do when you see the 5, 7? You write x minus 5 squared plus 7. So the only thing is, what happens here? This measures squared change, right? So if I go from 5 to 8, the squared change is 9. I know the linear change is 3, but we're squaring. So that becomes a change of 9, right? Because you're squaring that change. And if I want to get from 7 plus 9 is 16. Well, what if I wanted to get 17? 9 doesn't work. What works to get from 7 to 17? 10 works. That's that function. All right, now let's try another one. So let's do negative 4, 7, and it might be helpful to actually come over here. Negative 4, 7. I'm sorry, I did not mean to do that. Negative 4, 7. There, that's your x and your y. And if I go to 0, 20, all right, then 0, 20, I look at my change. Well, change is 13. So I know that x plus 4 squared plus 7, I know where that 13 goes in the change in y, because that's all I'm doing is the change in from y1 to y2. That's all I'm doing in the numerator. This, however, is squared change. So what is the change? It's 4 units of change, but if you square it, you get 16. And I don't want 16 plus 7. Doesn't take me to 20. 13 plus 7 takes me to 20. So I've done a conversion. The change I got isn't what I want. I cancel it out of the problem. And I could have looked at this from the standpoint of x plus 4 squared, right? I'm going to plug a 0 in. Whatever I get, I probably don't want. So there's your cancellation. All right, let's do another one. Let's do an upside down one here. All right, so let's do this. Negative 6, 5. And let's go to, I don't know, negative 2 is bigger than negative 6. And let's go from 5 to 4. Okay, so what do we have? We've got negative 6, 5. So you're going to say x plus 6 squared plus 5, I hope. And you're going to put the change in y. Well, there's my first y. There's my second y. How did I get from 5 to 4? You got to be careful. You went down 1. Well, if I got a negative multiplier, it's cup-shaped down. Okay, so then I've got what? The change is 4 units. Okay, from negative 6 to negative 2 is 4 units. But what am I doing? I'm squaring. I'm squaring that change. Well, that's 16 units of change. That's what we had the last time. That's what we got again. All right, and I think we'll do one more. And then I'm going to upload this, put it on Canvas. And you got 5 problems you're practicing. And I did, I think, another video yesterday. Start accessing those videos. Look for rapid fire. All right, I'm going to call this rapid fire 5 problems. I don't know what I'll call it, but something like that. So let's do, how about we do AB to CD? Let's give you a little formula. All right, what's this formula? It's x minus a squared plus b. Now when I put c in, I get c minus a squared plus b. And I want that to equal d. Oh, God, that doesn't work. So I get rid of it. C minus a squared, it's gone. Boom, if I put it here, c minus a squared, it's gone. Okay, that's good, but I'm still stuck with, when I put c in, I got 1 plus b. I want that to be d. Well, I think I got to multiply it 1 times d minus b. So that's what goes here. Now, what is D minus B in your algebra 1 language? Y2 minus Y1. That's really what it is. So I left you with kind of a challenge there at the end. But if you replay it and it makes sense to you, then you've really come a long way. All right, so that's it. I've been here a long time today. It's now night and I'm getting out of here. See you tomorrow. I got to write your test too, and an answer key. Shoo.